So thank you for joining me today.
Well, thanks for having me. Happy to be here.
It's a pleasure. And Tim, thank you as well.
Pleasure.
So we have a tradition here at Zoe where we always start with a quick fire round of questions from our listeners. And we're very strict rules. You can say yes or no, or if you absolutely have to, you can give us a one-sentence answer. It's designed to be really hard for professors. Are you willing to give it a go?
Sure.
All right, starting with you, Valter. Do we have more influence over aging than we realize?
Yes.
Does having a longer eating window accelerate the aging process?
Not necessarily.
Tim, could having a shorter eating window give you more energy?
Yes, definitely.
Valter, can we get the effects of fasting while still eating something?
Yes.
And finally, you can have a whole sentence. What's the most surprising thing that you've learned about aging?
Probably that there is a way to turn on these reprogramming factors, Yamanaka factors and others, and rejuvenate the system without causing necessarily a lot of damage. So that to me, it was a little surprising when Belmont and others came up with it.
I'm definitely going to come back to that because you've raised more questions than answers for me at this point. So I'm very excited to get into it. I was actually thinking, just as we were getting ready for this podcast, that when I was younger, I never gave any thought to aging. I think like most young people, I just assumed I was going to stay young forever. Needless to say, I was wrong about that. And probably about many other things that I believed when I was 20. So now I'm in my late 40s and I find myself thinking about aging a lot more often and sometimes sort of worrying about that. So I'm eager to learn, how I could stay healthy for many more years. And I'm excited to talk about it with the two of you. Valter, could you start at the beginning about helping us to understand, what's the difference between our actual age by, number of birthdays and our biological age?
Essentially, how functional are you? How able are you to reproduce, to run fast, et cetera, et cetera? In fact, some years ago, I introduced the concept of juventology, to contrast gerontology, because it's also the concept of how young you are versus are you aging or not, right? So I think that we're missing this idea of youth span. I call it youth span, right? So juventology and youth span. So the measure of how young you are. So okay, if you're 55, can you still run like a 35-year-old, right? And so that's, I think, still somewhat missing in the field, the measurement of youth.
And Valter, if I'm 49 by the number of birthdays I've had, and maybe let's say that means I'm going to live for another 30 years. If you figure out my biological age is 39, does that mean I'm literally going to live for an extra decade? Is that literally what biological age means?
It means that your life expectancy is that, right? It's going to be prolonged, but it doesn't mean that you will live that much longer. But so on average, your life expectancy will be extended. Yeah.
So it's really like measuring the actual state of my body being like an average person who's 39 rather than 49.
Yeah, you are basically. I don't even know that we should use chronological age, right? So you are. Assuming that the measurements are valid, right? But if that's true, then you are 39, no matter what your chronological age says.
And is it possible to have a biological age that is very different from your actual age?
Absolutely, right? So there was a study years ago showing, I think they were all chronologically 38 years old, and some of them biologically were in their 20s, and some of them were in their 40s, and if not later. So yes, you can have 20 years of difference between chronological age and biological age.
We did this really, one of the big studies of biological age using the UK twins. And we'd measured about 3,000 twins of different ages. And whilst there was a rough correlation between your birthday and your biological age, within each age band, there was around a 20 to 25 year difference. So you could end up with a 40-year-old having a biological age of 65.
Wow.
And a 65-year-old having a biological age of 40.
And Tim, does that mean that if there was a 65-year-old with a biological age of 40, they're actually likely to live a lot longer than that 40-year-old who had the biological age of 65?
On the balance of probabilities, yes. I mean, at the moment, it's a rough prediction, but that's what it's showing, is that there's big differences between individuals, regardless of what your actual age is at that particular time. So this is why the whole field is, we're all living with different biological ages, and most of us don't know what they are. I think that's the really quite fun thing about this. We're obsessed with our birth date and being told that all 50-year-olds need to do this and 60-year-olds need to do this. But within that, there's this huge range. And this is what we see with, centenarians who may have obviously different biological ages and may be fitter than people 30 years younger than them.
Yeah, and of course, given that the sophistication of this biological aging method is limited, right? So we're going to find out that there are more limitations than we think, right? So, but initially you get excited because you get a correlation and you say, well, people that have this epigenetic profile, tend to die earlier or later. But then I think you realize that that's not as sophisticated as you think it is, right? And so probably going to modify. So maybe those 40-year-old that are chronologically 65 are not really 40, right? They may be 55, right? So I think that's probably what we're going to see. So to answer your question, they're probably going to maybe, an in-between, maybe die at the same time. Right?
Because I've done 3 tests on my biological age test, 3 different ones. One an epigenetic test, one a telomere test, and one using chemical metabolites, metabolomic test. And a 4th one, actually. I did something called glycan age, which is measuring these little sugars on your immune system. And, the majority pointed to me having a lower biological age than my other one, but not all of them. They don't all agree. So I've got, you can pick the one that suits you best. If you,
I was going to say, I think I would definitely pick the best one out of that. I know. So
but that's exactly the way to do it, right? That's the way to do it. Instead of getting the best one, use all 4 of them and then pick the average of the 4, because that's probably much more likely to give you a good indication of your true biological age.
And Valter, can I just walk into my doctor and say I'd like to get a test for my biological age, and they will say, sure, Jonathan, and take some blood and then tell me what it is?
Most doctors will now, either they know of a company that does this or they can find out. So most doctors, will be able to order you one.
And is there a specific test? What would be the test that you're referring to when you say that?
Different ones, right? So there's definitely the epigenetic one that's very common, both in Europe and the United States. So there are companies that do that. And they're just a kit, and they send you the kit and you send it back and they give you your biological age. And then I really like the Morgan Levine BioAge, which is based on blood markers. And I like that because the blood markers that she selected are disease risk factors like A1C and blood pressure, et cetera. And so I like that because, it'd be difficult to argue that somebody's got lower A1C and lower blood pressure and lower inflammation, et cetera, et cetera. It will not be younger biologically, right? So that's another one that doesn't even need any doctor can calculate it based on your blood markers.
There's one called telomeres, which is sort of measuring the ends of your chromosomes, which is been likened to the end of a shoelace. That as you get older, it gets more and more frayed and tears off, and that. The bit that's remaining is called the telomere length, and you can measure that, which was all very trendy about 10 years ago. It has some problems with it, but as you get older, it may not work as well. And the final one is just doing these chemical metabolites. You measure maybe 50 or 100 of these metabolites that are related to age, and you put them all together into a model and you can do them. So there's lots of different ways of measuring it. And there isn't really a gold standard as yet. And they all roughly agree with each other, but not 100%. So that's the problem. And some change with time more differently, don't they? So that makes it slightly difficult to interpret.
But those two would be less available. I mean, most doctors would not be able to get you a telomere test, and certainly not a metabolomic test. But I would say most doctors would be able to fairly easily get you the other two, right? Yeah.
It amazes me that so many of you watch and subscribe to this show. We now get more than 2 million views a month on YouTube, which is a number I find very hard to comprehend. 2 years ago, when we started this podcast, I guessed it would be a few thousand of you tuning in at most, and that the show would serve mainly to keep our Zoe coaches informed about the latest science so they could help our members. I felt pretty great when so many chose to tune in from the start, and that so many continue to tune in each week. So we'll continue making Zoe Science and Nutrition and do everything we can to keep making it better. And if you appreciate this, there's a simple free favor that you can do for us in return. Hit the subscribe button below. That's it. Thank you, and on with the show. So I'd love to go on having established that there is this difference between like our biological age from just how many years since we're born, understand more about how we age. And Valter, I think yeast has helped you to make some breakthroughs here?
Yeah, so I went from working with Roy Walford here at UCLA, was working on people and mice, back to yeast in the biochemistry department because I thought I wanted real answers, right? So the genetics of aging was starting, right, back in the early 90s. And so I decided that it was probably better to work with something very simple so that we could identify the genes that control the aging process. And we did, right? So we identified, in fact, my lab was the first one to identify the TOR-6 kinase pathway in aging, in yeast, and this was in 2001. So rapamycin blocks this pathway. It's called TOR-S6 kinase. And so rapamycin now, I would say, is probably the one genetic pathway most recognized to affect longevity in all kinds of organisms, right? So
could you explain to me in simple words what that means?
Yeah, so it basically means that if you think about eating and proteins and amino acids, right? So proteins and amino acids activate, they do lots of things, but one of the things that they do is activate this pathway, this set of genes that have to do with cell growth and cell function. And at the center of that is TOR, T-O-R, and then downstream of that is something called S6 kinase, right? So when you have certain amino acids, high levels of certain amino acids and certain factors in the blood, that this TOR is activated, and this is now recognized to accelerate aging in all kinds of organisms. There was a famous paper following mine in the early 2000s that then was done in mice in 2009, published in Nature, showing that using this drug called rapamycin, blocking TOR, extend the lifespan of mice in 3 different laboratories, one in Michigan, one in Texas, and one at Jackson Laboratories.
So a simple way to describe all of this, I think, is perhaps nutrient sensing in all the cells. So this idea that all our cells have the ability to sense things like how much protein is around and maybe also perhaps glucose, that this is key. These sensors are then key to how much the cells are going to grow or repair. And I think this is this new concept, regardless of the details of the actual mechanisms of the pathways. We all possess, for some reason, these cells are really tuned in to knowing what's going on in terms of proteins and sugars and possibly also fats. And that regulates how our body repairs itself or grows or prevents aging. And I think that's what we've shown. And some of these drugs will either stimulate or block these systems. And that's really what Valter's been discovering.
And are you saying that if you have too many nutrients in your blood, that actually makes you age faster?
Yes. So, well, let's say that it's not really about too many nutrients. It's about certain nutrients. And so certain amino acids and certain carbohydrates. And so in the case of yeast, if you had a lot of sugar and then you activated this second pathway called RAS and a lot of amino acids, TOR, so TOR and RAS together, if you block these pathways, then the yeast live 5 times longer, right? So if you block the sugar pathway and you block the amino acid pathway, then the yeast live 5 times longer. If you did this and then you starve them, it lived 10 times longer, right? So that means that other pathways, there are additional pathways other than the sugar and the amino acid. They were involved in accelerating the aging and the mortality of the yeast, right? So yeah.
Can I ask a really naive question? I would have thought that having more nutrients would be better for living longer because I'd have all these things to, feed me and repair me. Why is it that having more of this is actually bad?
It probably has to do with reproduction, right? And the force of natural selection, meaning that we're here and every organism is here to reproduce and get out of the way, essentially, right? So then if the nutrients are low enough that you cannot have a normal course of reproduction, now you enter a maintenance mode, and evolution is basically come up with an alternative state where you can have a longer opportunity. So there is, if you have not enough nutrients, then the offspring cannot survive, cannot be born and cannot survive. And so, you wait until that opportunity comes around again. And this is why yeast and bacteria and all kinds of organisms you can put in starvation condition. They're standby. In fact, in yeast, it's really remarkable because, of course, we extend the lifespan by tenfold. But there is something natural called spore state. And in the spore state, they live 100 times longer, right? But they're in what's called a diapause. They're just, hibernating, if you will. So they're sitting there. And they're waiting for years for the opportunity that food is going to come around, and now you can grow, right? And you have your opportunity to reproduce, right? So there's 100-fold difference between state one, so the normal state, living in the fast lane, and this spore state where you live very slowly but for very long. Yeah.
I'm thinking about analogy with my iPhone. The power gets low and it goes into this like power saving mode, and suddenly the battery goes for much, much longer, but it doesn't allow me to, watch Netflix and get my, email at the same time. Yeah. And is there sort of an analogy here that it's sort of saying, well, the availability of these nutrients is lower and I'm setting my whole body to just like last much longer, but equally well, because I need to sustain myself until the point that I'm going to get these more nutrients, or in my iPhone, plug it back into the power supply?
Yes, absolutely. But now the science is basically now looking for, well, maybe you don't have to be in hibernation. You could be in a very active state, but maybe not reproducing. And so most people don't reproduce very many times in their lives, right? So why are we always in a pro-reproductive mode? Why don't we get into maintenance mode, be very functional and very active, and then so utilize this protection, and then, of course, exit from it only when we need to reproduce, right? So now you can exploit all this knowledge to age more slowly without having to hibernate.
Does everybody therefore age sort of at the same amount, or does this depend? So that, I might age at a completely different rate than Tim because of the way that, my biology is working?
No, it depends. But fundamentally, everybody ages by the same processes. But then, two people can age very differently, right? So we know that we've been following people in Ecuador. I mean, both mice that have a growth hormone receptor mutation, so they lack the keyhole responding to the growth hormone, right? So if you have a lot of growth hormone, the receptor is activated, and they're lacking this receptor, right? So they're not able to. It's like they didn't have any growth hormone. And the mice live 40% longer. And people, we don't know if they live longer, but certainly they rarely get diseases, right? They seem to be as protected as the mice against diseases. But they're basically saying a single mutation in a single gene can revolutionize not only the lifespan of the mouse, but the health span of the mouse. And so clearly, two people can have different genes. And so just these different genes can make a big difference. And by the way, we suspect that in Sardinia and some of the other places in the world where there is these blue zones, even though this is not being talked about a lot, we suspect that a big component was genetics, right? So the group of people in Seulo, Villa Grande Strisali, some of these little towns that have record longevity, they were born with the right genetic variants. And so they were predisposed to live longer, and then the lifestyle and the food, et cetera, made it even better. So that's probably a good explanation for them, yeah.
We looked at this in our twins, the genetics of aging. There is a genetic component to aging, but across the whole population, it's actually less of an effect than for most common diseases. So we think that the contribution at a population level is only about 20% heritability of that effect. But as Walter said, there might be certain families or certain areas where they have a concentration of these genes. But across the board, 80% of aging, I think, is probably more environmental, apart from these special families, which was a bit of a shock at the time, because we thought actually genes would be the answer to most of aging and longevity issues, but it turns out not to be true.
Yeah, but now keep in mind, this is, let's say between twins, but genes are really completely controlling generally the lifespan, right? What does it mean? It means a mouse lives for 2 years versus 80 because of the genes, right? So genes can make a mouse, and that's what I was saying earlier. Just a mutation in one gene can make that mouse live 40% longer. Now, in the general population, most of what determines whether a twin lives longer or shorter is lifestyle and other things that happen to you, right? And so genetics are less important. But if you manipulate genes, there's limitless potential, right? So as we know, let's say if a rat lives more than a mouse, so there is genetic difference between a rat and a mouse are minimal, but that's enough. And a monkey, the difference between us and monkey genetically is very small, but those 1% or whatever is responsible for almost a tripling of lifespan, right? Between humans, if you just look at the population, most of the reasons why people live longer do not have to do with genes, but with probably lifestyle choices.
They changed one gene in the mouse, they then reduced the number of calories each day, and it lived twice as long as its sister mouse where none of that happened.
Yeah.
That is remarkable. Can I move us on? Because I think we've understood now that aging can be very different between people. And I think everyone listening to this wants to be in the group where their biological age is much lower than their chronological age. And I know this is really your big area of focus with your research on aging and longevity. And I understand my team tells me that you got a spot on Time magazine's list of the 50 most influential people in healthcare. And they referred to you as the fasting evangelist, which I love. So I'd love to talk about fasting and how it can connect to this aging process, because obviously nobody listening is going to be able to change their genes at home, but clearly they have a lot of control over their food. Could you start by taking us through what happens to someone's body during a fast and why that can be linked to what happens in terms of the aging in their body?
I always, challenge everyone with the question, find me anything that will revolutionize gene expression more than fasting. And I still haven't got anybody to even come up with something that they think could challenge it. Meaning, if you fast a person for, let's say, 5 days, it'd be hard to find something else that causes more changes in the body than those 5 days, right? Of course, if you go longer, even more changes. But I say anything you can do in 5 days. So everything happens during fasting for obvious reasons, right? So you now can no longer rely on energy coming from the outside. You need to rely on energy coming from inside. And so the body slowly gets into a modality where it starts burning fat and relying on fatty acids and ketone bodies. And ketone bodies are this, you heard of ketogenesis. And so ketogenesis refers to making these ketone bodies that are byproducts of fat breakdown, essentially. Breakdown and then reprocessing. So, for example, the brain, after 3 or 4 days of fasting, starts functioning both on glucose and on ketone bodies. And the heart can function using fatty acids, and other organs use fatty acids, which is basically fat, breaking down. Fats that are broken down. Then there's something else that's called glycerol that is released, and glycerol and amino acids coming from muscle and other systems, they can be used for gluconeogenesis. So now the body can make its own glucose because, of course, there's no carbohydrates coming from the outside. So these are just some of the examples of the things that happen in a human body in the fast. Now, a lot of people use words like autophagy and thinking that's going to happen, very quickly. So autophagy is this process where cells begin to eat themselves, right? Eat their own components. So they shrink and they start eating themselves.
So, Valter, that's a good thing if your cells are eating themselves? It doesn't sound like a good thing.
It is a good thing, right? So, and so these bacteria do it, and yeast do it, and all organisms do it. So it's an opportunity to get rid of a lot of normal components, but junk, real junk that accumulated in the cell. So in that sense, it's an opportunity to clean up. And so it's a good thing. Our group that we collaborate with has done a clinical trial showing that the markers of autophagy don't seem to be measurable until about day 5, end of day 5 in the human blood. But that's one of the things that people fast for 3 hours and they think autophagy is on, but it probably takes about 5 days to get there. Yeah.
So just to play back, you're saying that if you got into a state where your cells are actually sort of eating themselves, they're getting rid of sort of damage, that could be good, but you'd actually have to starve yourself for 5 days before that would happen.
Yes, of course, and I think we're going to talk about it. So we've been working for many, many years on how you don't have to starve yourself to get some of these effects, and that's where fasting, mimicking diets, and other things come in. But yes, normally a person will have to do, let's say, water-only fasting for 3, 4, 5 days before they see this, at least some of the cells. Now, we don't know what other cells do, but let's say the blood cells, they seem to be going into this autophagy process by day 5.
So if you're not willing to fast yourself for 5 days, is there any positive impact on your body from fasting more rapidly? Because you were talking about how it transforms your body in 5 days. Most people listening are probably not going to fast for 5 days, but obviously there's a lot of interest in intermittent fasting or all these other sort of things. Is there any impact on your body from shorter periods of fasting?
Yeah, so there's lots of different types of fasting, and each can have problems and solutions. Now, the one that I like after doing this for a long time is one is called time-restricted eating, something that Sachin Panda and others have worked a lot on. And in time-restricted eating, like with all things, people started abusing it and started doing 16 hours of fasting per day or 18 hours or 20 hours. And so I was against that, and I'm still against that because those 16 hours and even 14 hours or longer are associated with lots of side effects, lots of problems in the long run, right? And one of them is gallstone problems. But the worst one is the association of breakfast skipping with increased cardiovascular mortality, increased overall mortality, right? So there's meta-analysis on this, meaning studies of all studies indicating that. This is why I was always against it. And now there's a group that is suggesting that even if you skip dinner, this could be problematic. So I think instead the 12 hours time-restricted eating is the one that I never met a doctor or anybody that argue with it. And yet most people eat in America, and I'm assuming in the UK, for about 14 to 15 hours a day, right? So that means they fast for only, let's say, 9 hours or so. So I think that going back to 12 hours of fasting and 12 hours of feeding, which most people say, well, that's normal, that's a normal eating pattern, fine, call it whatever, but that seems to be very, very good.
It's come up on various podcasts about various benefits you might get, but does this actually affect the aging processes that you were talking about that could make us sort of stay healthy for more years?
I mean, the mouse studies will indicate yes, and I think we're starting to see some studies indicating reduced biological age, but I don't know if anybody's ever tested the, say, 11, 12 hours of eating. Most studies have looked at longer ones, right? So longer interventions, of course, are going to have more benefits and might even reduce biological age more dramatically short term, but it doesn't mean that they're going to make your life longer if, in fact, there is this association with increased mortality is correct, right?
You're saying for people who are fasting for more than 12 hours a day, you're talking 14, 16, 18 hours of fasting, you're worried that although you might see short-term benefits, you're actually concerned that in the long term, you might actually die sooner rather than actually be healthier?
Yes, and I think this is the concern with lots of drugs and lots of interventions, like, say, GLP-1. So lots of things are beneficial short-term, but then, medicine is not really set up to think about long-term effects, right? So, yeah. So, and I think fasting, because it is so powerful, is in the same category. But the 12 hours, I've never seen any negative studies, epidemiological or otherwise. So I would say that that's a very good recommendation. It seems to be working for aging. It seems to be working for metabolic issues, not as well as the 16 hours, but well. And so I think that's a good, safe option to the 16 hours.
Getting older, I've realised that what I eat makes a massive difference to my health. Now I'm eating the things that help my body feel great. With Zoe, I've got actual science to guide me, and my test results help tailor my advice. I'm making smarter choices every day, like what to add to my plate. It's like having a nutritionist in my pocket. It's changed everything. I'm living my best life. I'm going to be clubbing with the grandkids. Join me and over 100,000 people transforming their health with Zoe.
Tim, I'd love to bring you in here, both because I know this is something that you study quite a lot, and also because Zoe conducted a study on, I think, about 150,000 people, didn't it, on intermittent fasting. So I'm really curious about your view and what we found there, but also more broadly.
Yes. So we did what we call the Zoe Big If study, which was time-restricted eating, not actual fasting, but so it was just trying to see what it was when you went to the general population rather than specific, volunteers in a lab, which are not generalizable. How easy would it be for people to do? So we had 140,000 people from our Zoe database that signed up for this program, and we said, okay, we want you to do 3 weeks where you're eating in a 10-hour window and you're fasting for 14 hours. Which I still think is reasonable. I think somewhere between 12 and 14 hours. I believe the evidence shows that's still safe. We can disagree on some of the epidemiology, but I think, whereas more extreme fasting, I do worry as well about that. So we were asking people to do a modest change. And what was really interesting is that a third of people found it really easy to do this. And they actually carried on well past the 3 weeks. They went on for 6 months. And those people got real benefits in mood and energy. They lost weight, and waist circumference improved. And they actually had less hunger by doing that. So they really liked it. A third of people never found it too much, and they didn't actually get started. And a third started and sort of gave up. There are certain people that it probably really suits, and they feel very comfortable. It feels natural to them, and they get into it, and I think they will get benefits. Some people do find it rather hard to go long periods without eating, and that just showing this, as we know at Zoe, all about personalization, that, there are these differences between people that make it harder or easier. So, yeah, I'm all for this not too stricter time-restricted eating, but it not necessarily for everybody. We didn't try the 12 hours, so it could have been that most people, it would be even easier to do the 12-hour.
But what was did you actually ask them what they actually did?
Yes.
You told them to go 10 hours, but did they do, because in the studies of Sachin Panda, he tells them 10 hours, but then it's about 11, right? So it gets closer to 12. So do you know what they actually was that they did?
Yes, we did. And a third did it quite sort of religiously. And there was this middle group that actually went back, and probably managed 12 hours most of the time. But they didn't seem to get quite the same benefits. But I think, but realistically, what's more important is that people sustain this for long periods of time. Therefore, I agree with the general principle that having more modest goals is people are more likely to adhere to it long term and get benefits than really going for some superhuman effort.
Now, I know you've developed something called the fasted mimicking diet. And so I'd be interested to understand what that is, because I think this ties into this question around how can you do something that's sustainable and something which is trying to get these aging benefits. Could you explain what it is and why you think it's still beneficial for longevity?
Yes. So I mentioned my second favorite fasting intervention, which is time-restricted eating. But my favorite, of course, is what we developed in my lab. which is, looking at fasting more like a medicine, and when do you need to fast? And so starting a long time ago, I knew, we first did a trial, I think it was 2010, on cancer patients. And we were testing the hypothesis that coming from mice, that if you treated mice with chemotherapy and you fasted them before you treated with chemo, they were much more resistant, but the cancer cells were much more sensitive, right? So we brought this to the patients and USC Norris Cancer Center nearby here.
And Valter, you asked them to fast how much before?
For 3 days.
So they have to eat no food or anything for 3 days.
Yeah. And now this is 2010. Now everybody talks about fasting. And in 2010, it was not like it is right now. So they were worried, and the oncologists were worried. Everybody was worried. And so it took forever to finish that trial. So then we went to the NCI, National Cancer Institute, and National Institute on Aging, and they funded research for fasting mimicking diet, right? So it was first funded by the NCI and then by the NIA. And and the idea was very straightforward. We knew the sort of relationship between food ingredients and these pathways, TOR and RAS and all of that. And so we just played with that knowledge. We utilized that knowledge to then got to a point where we were looking for 4 markers: IGF-1, IGF-PP1, glucose, and ketone bodies. They were fasting response markers, meaning that we wanted to match the effect of the fasting mimicking diet and water-only fasting on this fasting response, right? So once we achieved that, then that was it. That was fasting mimicking diet. But then we combined that with the idea of periodic fasting. Let's say we think that if most people were willing to do daily changes, we would not have Americans 75% overweight and obese, British 60%, Italians 50%. So we thought maybe there is a periodic way to intervene, right? You can do the fasting once every month, 2 months, 3 months, and water-only fasting first. And then, of course, then we say, well, even better, what if we did a periodic fasting mimicking diet? So then we've done lots of trials, I think 35 trials already, looking at this periodic fasting mimicking diet. And so this is a low-calorie, low-protein, low-sugar, high-fat, plant-based diet that lasts between 4 days and 7 days, depending on what we're trying to treat. Then the patient gets a box, and that's a medicine, right? Or that's potential medicine, let's say. And so we tested it now for lots of different things. I think the most advanced ones is diabetes. Now, very clearly, we're seeing regression, diabetes remission. And the beauty, I think, is with that lifestyle changes, right? So we ask, and the University of Leiden trial with 100 patients actually looked at lifestyle and saw no difference other than a little bit increase in exercise towards the end of the 12 fasting mimicking diet cycle. So they did monthly. So these diabetics with doing fasting mimicking diet once a month for 12 months. By the end of it, they saw—
How many days per month?
5 days.
5 days per month.
Yeah, 5 days a month, and then they were allowed to go back to whatever it is that they do. But now the beauty is that they improve so much. 70% of them reduce drug use. They improve so much, then we basically think, and we've seen this, we have clinics for my foundations, and so that we can switch them to 3 or 4 times a year. That's it, right? So year 1, you do it 12, maybe not even 12, but let's say 12. And then year 2, you might be able to go down to 4 to 6 cycles. And year 3, we're hoping you're down maybe to 3 cycles. And that's it. So you do it once every 4 months. And so now we're formally testing that in southern Italy in a 500-patient trial, 3-arm, and one is a control fasting mimicking diet once every 3 months. And then fasting mimicking diet every 3 months plus what I call the longevity diet. And so we'll see, we're now at patient 400. And so we've got 100 patients left. But yeah, the idea is, yes, we can try to get people to change everything they do, but they're probably either won't change or they'll go back to whatever it is that they used to do. But maybe if the doctor was on board once every 3 months, if you have a problem, you can consider doing these 5 days. And once you're done with the 5 days, you're done for 3 months.
And Valter, it's because you talked about diabetes here, but before we were talking about longevity, do you believe that this sort of fasting mimicking diet, this 5 days, sort of every few months, can improve, the biological age, make you younger on the inside that we were talking about at the beginning of the podcast?
Yeah, so we did that in 2 trials. Right? And in both trials, 2.5 years of biological age reduction after 3 cycles. So this is using what I was telling you earlier.
Let me just play back. You're saying that you did it 3 times and your measured biological age improved by 2.5 years.
Yeah. So subjects that were asked to do the fasting mimicking diet monthly for 3 months, they showed a reduction almost identical in both trials of 2.5 years on average.
Tim, what's your reaction to that?
It's very exciting that you might be able to trick the body into this state. And I think the question is whether this is sustained over time. Because you might get a temporary change in these markers of biological age. But I do think what I like about it is that it's accepting that people aren't going to do long fasts for long periods of time outside a laboratory. And so it has a pragmatic element to it, which I think is really exciting. So I think the test will be, these long-term studies to say, well, at 3 or 5 years, have things really changed permanently, or is this a temporary? Will the body reset itself? I guess is always, this is what we're always fighting in medicine is the body's ability to recalibrate and realize it's being fooled. And the question is, it seems to work short term. The question is, is this going to work long term? But it's very exciting.
As part of several trials, we did a 3-month follow-up, and about 40% of the effects are gone after 3 months, right? So yeah, it makes sense that you will have to keep up every 3 months. And now in the Italian trial, we are doing a second follow-up trial. So the patients finished the first 6 months of treatment, and now we're starting a 1-year follow-up after they're done with the 6 months, right? So then we're trying to see in those that had benefits after the 6 months, can we keep them for another year, and how much of the changes do we keep? So we just published one of the many papers. The latest one was on kidney, and we're showing that the fasting mimicking diet. This we did usually was mice and people, and now this one was rat and people, and so in the rat, so we used a toxin, kidney toxin, and we damaged the kidney, and then we started the cycles of the fasting mimicking diet. And you see the kidney basically turning on these developmental genes, right? Including Yamanaka factors, these reprogramming factors. So these factors that have the ability to turn any cell into a sort of young pluripotent stem cell. So you see that the kidney is basically being reprogrammed to go back to a normal state. So we have pictures in something called spatial transcriptomics. So it looks the profile of a gene expression and the different cell types. And you see that the toxin completely disrupts this, right? And then you start the fasting mimicking diet, and everything goes back in the right place, right? You see these developmental genes being turned on, and then everything returns to normal, as if the body has always had the ability to start from zero, right? And so I always say, if you cut yourself, after a couple of weeks, this wound is repaired, right? Is it possible to deliver the pancreas? And lots of the human organs now have the same ability to truly reset. They have the information, right? And this is why I was saying earlier about the Yamanaka factors, and I'm really impressed with the work by Belmonte and others in forcefully turning on these Yamanaka factors, and we can talk about it.
So the kidney was damaged. When you then just applied this diet and nothing else, no other drugs, actually sort of a whole set of repair mechanisms got switched on in this rat that basically healed this problem. And I think you're saying that would not normally have happened?
No. Normally you will have damage, and permanent damage, or certainly long-term damage. And now we did it in a randomized crossover small trial pilot, 13 patients, 7 and 6. And we saw a patient with kidney damage, a kidney disease. We saw long-term effects, 12 months. After 12 months, they were still, just by doing 3 cycles of fasting mimicking diet, they were showing, long-term benefits in proteinuria and other markers of kidney disease. Now, small, but now because we have larger trials in other type of diseases, I think it's certainly very promising.
So you're now doing a set of studies in human beings for this diet to see whether or not you can deliver the same sort of benefits you've been seeing in these animals.
Yeah, most of these studies are not even done by us, right? They done by universities. So Heidelberg did one study on diabetes, University of Leiden did the other one. Stanford is now doing a study on Crohn's disease, another one on colitis, University of Miami. So I think I'm just helping everybody. We did it in mice. We did the work in mice and rats. And then the one that I just mentioned is University of Rome, right? University of Rome did the 13-patient kidney disease a clinical trial, right? So we're basically telling the story, and then we help them develop the trial, and then usually we get a call from Stanford now 3-4 years later. I cannot tell you the results, but certainly I got a call a week ago. Say we're done, and let me show you the results. Yeah.
So I think we've heard how this fasting mimicking diet works, and the science that sort of would link that to hopefully, longevity and more healthy years. So if someone wants to try this themselves, your recommendation is that they don't do it on their own, but they follow a very specific protocol. Could you just give me a high-level understanding of what that is?
Yeah, so there is a protocol, a clinically tested protocol, and a clinically tested fasting mimicking diet. So people should do the clinically tested fasting mimicking diet. And basically, it's usually between 600 and 1,100 calories, depending whether it's used for cancer or diabetes or people that don't have any problems. 600, 1,100 calories per day, and it's a low sugar, low protein, low calorie, and high fat. The version for people that don't have diseases, right? So that version is 1,100 calories on day 1, and then it goes down to about 770 to 800 calories on day 2, 3, 4, 5. And again, the plant-based, high fat, low sugar, low protein.
Is there a sort of time restriction within when you eat this? Is this like one meal a day? What does it look like?
The general recommendation is to do the 12 hours. But we felt that we don't want to add burden to burden. And so in clinical trials, we never give instructions to do time-restricted eating.
Because it's not like you have to eat only one meal a day or something like that. You can sort of spread this across
this is
the day.
More like 4 or 5. Yeah, 4 or 5, let's say breakfast, lunch, snack, dinner.
And so the key thing here is that the amount of calories is much lower than usual, and that the types of food are quite different. You're trying to restrict sort of the amount of blood sugar and things like this in what you're actually eating.
Generally, we're trying to cause a fasting response, but we're also trying to not exaggerate that fasting response, right? So, for example, there are starches in the food, and some of the starches are there also because we don't want people to abandon it. I also imposed the starches because I did not want ketone bodies to go very high. I did not want this yo-yo. I was afraid that if somebody did that for 20 years, they'll end up every month, let's say, which we don't recommend, by the way, that somehow will be associated with a problem. I don't know what the problem would be, but I was worried. And so the starches in there have the job of not making that ketogenesis too high, right? So we don't want to push people into extreme states. We'd rather keep them maybe a little bit less effective, as I was saying earlier about the time-restricted eating. Yeah, you could do 16 hours, you get bigger effects, but I'd rather be safe with 12.
So it's not a ketogenic diet. It's not 70% fat to cause that.
So it's 45% carbohydrate, 45% fats, and 10% proteins, but it's severely calorie restricted, as I mentioned.
So Tim, I think we've heard a lot about the anti-aging through fasting. Is it all about fasting if we're thinking about anti-aging, or are there other things that you would think about?
No, this is super interesting, and definitely has a place. But just fasting, if you've got a terrible diet, is probably not going to work. So I think the other message is that your daily food you're eating when you're not fasting is also really important, because we know that particularly ultra-processed foods are going to be pro-inflammatory and inflamm aging, which is this concept that our immune system is just triggered all the time, accelerates aging, I think is getting increasingly recognized in the field, so that people ought to be thinking about that who are interested in aging, is cutting out ultra processed foods right back to levels below 10%. Currently in the US, they're above 60%. So major reductions in that ultra processed food, which affects your gut microbes, which affects your immune system, really important, as well as eating more plants and looking after your gut microbes, because your gut microbiome is really linked to your immune system, which has really important effects on dampening down this inflammation and helping the aging process. So I think, like all these things, a holistic approach is important. So diet, maintenance of muscle mass, exercise, whatever. So don't forget the bigger picture as well if you are going to go for time-restricted eating or these fasting mechanisms.
Thank you both. We've definitely hit time. I've really enjoyed it. It's very interesting. I think I may have only understood half of it, but Tim's going to explain it all to me afterwards. I'm going to try and do a quick summary and correct me if I get any of this wrong. I think the first thing we took away is that biological age is absolutely not chronological age. So you might have 49 birthdays, but actually your body, you could have the body of a 35-year-old or a 65-year-old, and that is based upon, the lifestyle that you're going through. So that's really meaningful. And you said that if my biological age was 35, I genuinely could be living another sort of 15 healthy years another way. So I think that's very exciting that you have that control and that the science is really saying that. Valter, you then taught us a lot of the different science you've been doing. And the thing that really stuck with me is this idea that you were sort of doing these mice experiments and you're saying you could change one gene and calorie restrict them and they could live twice as long. So there's this ability to really transform how long, animals and fungi and these sorts of things live. And that in your research, there was nothing that can have as big an impact of fasting in just a few days on people. So there is this thing that fasting has this sort of profound change in our biology. And you were describing, it has to, because otherwise your body would die. So it makes this really big shift. And I think we talked about two things. We talked about time-restricted eating. And you said, actually, you really do believe that sort of limiting your eating to 12 hours of eating, 12 hours of not eating could really help you stay younger. So that is even I can do that, right? That is an achievable thing for almost anybody. Had a bit of a discussion about the duration. I think Tim said he felt very comfortable you could go to 14 hours fasting per day without negative impact. I think you both agreed that going to very short windows of time when you eat, 6 hours or maybe even 8 hours is probably not healthy. Is that, Tim, am I saying that fairly?
Yeah, you should be concerned, definitely.
So some discussion about, I think, general alignment. Tim maybe saying a bit more flex about the time, 12 to 14, but both agreeing that going to very short periods of time, in your opinion, is not going to make you live longer and is probably actually the reverse. Is that
in the opinion of epidemiology?
Perfect. And then we talked about this fast mimicking diet that you've been building based upon all your research, which I understand is sort of this idea that you eat this special meal, which is both, it's reduced, it's very much reduced calories compared to normal, but it's not absolutely fasting. It's carefully designed to have sort of the nutrients in it that sort of trigger a similar response as if you were fasting, but without actually having to starve yourself completely. That you do that for 5 days, then you have the rest of the month off. You do that again for 5 days. You've done
the rest of probably 4 months, right? That's what we think realistically 3 times a year, if not less. And do it only when you need to do it. It's not about doing it as frequently as possible so you can live forever. It's about don't take any chances, do it as little as possible, but do it when you need to do it.
And you have done, some studies. I think the one that I remember now is the one where you did sort of 3 cycles monthly, and you said those individuals on that study, actually their biological age improved by 2.5 years. So in human beings, you did that study, it's short term and you're now looking at the long-term follow-up, but you've seen real responses to that. And I think what you're saying, if I understand, is clearly it's still hard work to do that. So you want to do that sort of as infrequently as possible to get the benefits.
Not just hard work. We don't know what the negatives could be long-term, right? This is why we want to say, if you need to do it because of whether it's weight or diabetes or lots of other things that we've seen being useful for, then you need to do it. But if not, then let's wait. That's okay. Wait until we have more data and long-term data, and we'll see.
Brilliant. And then I think we wrapped up, Tim, with you saying that from your perspective, fasting alone is not enough, that we need to think about the diet that we have all the rest of the time. And that in particular, if you're eating like this, high levels of ultra processed food and then think that sort of just fasting is going to fix it all, you're skeptical about that. You need to think about the whole thing.